Today we're going to look at graphing the tangent and the cotangent functions. We're going to look at the unit circle, and we're going to look at what are the tangent values on our given the radians or degrees around the circle. Remember, tangent is your sine value over your cosine value, so the y over the x. So if we look at 0 radians or 0 degrees, the tangent of 0 is the y value of 0 divided by the x value of 1. 0 divided by 1 is 0. Tangent of pi over 6, the y value 1/2 divided by the x value square root of 3 over 2. 1/2 divided by square root of 3 over 2 reduces down to square root of 3 over 3. Tangent of pi over 4, square root of 2 over 2 divided by square root of 2 over 2 is 1. Tangent of pi over 3, square root of 3 over 2 divided by 1/2. Square root of 3 over 2 divided by 1/2 is just the square root of 3. Tangent of pi over 2 is the 1 divided by 0. Dividing by 0, can't do it, gives me undefined. We'll have an asymptote there at pi over 2. And I keep going around. Let's just look at the ones that give us like almost an easy answer. 3 pi over 4, that's obviously the y value divided by the x value is just going to give me -1. And down here at pi, 0 divided by -1 is 0. Okay, and I could keep looking a little bit further down my unit circle. So here I have negative square root of 2 over 2 divided by negative square root of 2 over 2 is just +1. 3 pi over 2, tangent of 3 pi over 2, -1 divided by 0 again is undefined. 7 pi over 4 gives me -1, and back up to 2 pi I'll be at 0. So here's my tangent, the tangent function, and these are the values that I get at different radians around the unit circle. And we want to just look at, one question I want to ask is, when do you think the tangent function, or what is the period of the tangent function? When does it start to repeat itself? So pause the video, answer that question quick, and come on back. So the tangent function is going to repeat itself. Well, let's take a look here. When did the values start repeating? I started at 0. Let's just look at the ones that I highlighted in yellow, because those are just the easy values to take a look at. We have 0, we have 1, undefined, -1, and right here we're back to 0. And then we come down, we go back to 1, undefined, -1, and then back to 0. So where did I start to repeat itself? Right here at pi. Tangent and cotangent will always have, now let me take that word away, always. Tangent and cotangent, the parent function, the tangent of theta, y equals the tangent of theta, or y equals the cotangent of theta, will have a period of just pi. So you only have to go halfway around the circle before the tangent values start to repeat. So the tangent has a period of pi. Y equals tangent of theta, period is pi. So let's actually take a look at how we're going to graph this. Let's just look at tangent first, and then we'll come back to cotangent. So grab worksheet T12, and if the period is 5, we know the increments that we're going to go up by are going to be pi over 4, or 1/4 of the period. So if we're going to go up by pi over 4 increments, we take 0, we're going to look at pi over 4, and then 2 pi over 4, which is 2 pi over 4 is actually just pi over 2. So we'll really look, pi over 2. Then 3 pi over 4. And then we'll look at just 4 pi over 4, which reduces to pi. And so just grabbing the values from the graph we just did, tangent of 0 was 0. Tangent of pi over 4 was 1. Tangent of pi over 2 was undefined. Tangent of 3 pi over 4 was -1, and tangent of pi was 0. So I'll put these values on my graph: 0, pi over 4, pi over 2, 3 pi over 4, and pi. And we'll go -pi over 4, -pi over 2, -3 pi over 4, and -pi. Go both ways. Now, tangent function does not have an altitude, but if I could say it had But the number in front still sort of matters. So we're gonna put that 1 there. Remember, if there's not a number in front, we know it's the number 1, because 1 times anything doesn't change the value. So I'm still gonna put 1 and negative 1 on my graph. They still help create a graph. And so if I graph these points, let me just first put in that asymptote at pi over 2. So at 0, I'm 0. At pi over 4, I'm at 1. And at 3 pi over 4, I'm at negative 1. And at pi, I'm back at 0. So if we look, here appears to be the graph that I see so far. But I want to really look at more values than just what's in the period, because I want to really see what the graph generally looks like if I continue my patterns. So let's just continue. This was 4 pi over 4, so let's 5 pi over 4. After 5 pi over 4, we'll be at 3 pi over 2. And then let's go to 7 pi over 4 and to 2 pi. Okay, so 5 pi over 4, 5 pi over 4 gives me a value of positive 1. 3 pi over 2 is undefined. 7 pi over 4 gives me a value of negative 1. And 2 pi is back to 0. So let's put in that asymptote again at, let's get my blue marker out, 5 pi over 4, 3 pi over 2, those are getting blurred, 7 pi over 4, and back to 2 pi, and I was undefined at 3 pi over 2. Oops. Alright, so 3 pi over 2, I put another asymptote. So what happened at 5 pi over 4? It was at 1. So here, we'll continue this. That's not a very good graph. 7 pi over 4, we're at negative 1. 2 pi, we're at 0. And what I want to start to do is I want to start to look for a pattern. So these are the ones that I continued to graph. But what's happening? There's 3 significant points in here. This negative 1, 0, 1. So let's just follow the pattern. Negative 1, 0. I bet you the next point's going to be at 1. And then the next one's going to be an asymptote. So what we can do is just follow the pattern. So let's go backwards. If this was 1, 0, negative 1, 1, 0, negative 1. Follow, and then we'll have an asymptote. Follow the pattern. The next one is going to start up at 1, 0, and then over here we'll be at negative 1, and then we'll have an asymptote. So 1, oh, that's an awful graph. Okay, maybe this is slightly better. But you get the idea. So there is what a tangent function looks like. Okay, so one thing to keep in mind, if you had, like, if we had, for example, like y equals 5 tangent of theta, although that's not tangent function and cotangent does not have an altitude, how that's just going to change it a little bit. We'll have our asymptote still, but it will be up here at 5 will be a significant point, 0 will still be a significant point, and negative 5 will still be a significant point. And so a graph like that, and we'll always, and then they'll keep coming. Oops, sorry, and so on. So 5 will still be a significant point, but here there's no number in front of the theta, so the period of this will still be pi. But if, for example, I have a value like y equals the tangent of 3 theta, well then my period is going to be pi divided by 3. Pi divided by 3 would be my period. So if I had to figure out what my increments I would go up by, I would take pi divided by 3 divided by 4. Well, dividing by 4 is essentially multiplying by 1/4. So I would actually, my increments I would go up by would be pi over 12. So pi over 12 would be what I would count by in my table, the increments I would go up by. There'd be no amplitude, and there's the graph, or there's just a couple little side notes that I want you to pay attention to. But let's get back to the cotangent function. Cotangent. So if we look back at our unit circle, and I look at my cotangent values. Now remember, cotangent is just a reciprocal of tangent, so cotangent is the x over the y this time. So x value divided by the y, 1 over 0, is undefined. And again, we're just going to pay attention to the easy values, I'll say. Square root of 2 over 2 divided by square root of 2 over 2 is 1. 0 divided by 1 is 0. Cotangent of pi over 2 would be 0. Cotangent of 3 pi over 4 would be negative 1. Cotangent of pi would be undefined. Coming on down, cotangent of 5 pi over 4 would be 1. Cotangent of 3 pi over 2, 0 divided by negative 1 is 0. Cotangent of 7 pi over 4, square root of 2 over 2 divided by negative square root of 2 over 2 is a negative 1. And back to 2 pi, 1 divided by 0, cotangent of 2 pi would be undefined. Okay, so we'll keep these values in mind, and let's go back to our worksheet where we're looking at cotangent this time. Let's look at cotangent. So when I look at cotangent again, I know my period is pi, so if I figure out what increments do I want to go up by, I want to go up by increments of 1/4 of my period. So pi divided by 4 is just pi over 4. So we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. So again, we're going to put our values in. At 0, we were undefined. Pi over 4, we were at 1. Pi over 2, we were at 0. 3 pi over 4, we're at negative 1. And at pi, we are undefined. So we'll put our values down here. Pi, oops, you can't see that. Pi over 4, pi over 2, 3 pi over 4, and at pi, we could keep going on. And we're undefined at 0. 0, we're undefined, so we'll have an asymptote there. And we're undefined again at pi. So what's happening, pi over 4, let's just define this as 1. What did I get? 1, 2, 3, 1, 2, negative 1. So pi over 4, we'll say is at 1. Pi over 2 is at 0. 3 pi over 4 is at negative 1. So essentially this looks like the same graph as cosine, but notice it's just changing the directional. Okay? So what in the cotangent is also going to follow the same pattern. So we're going to, the next value, guess where is it going to be? It's going to be at 1, you're right. And then at 0, and then at negative 1. And then we're going to have an asymptote. So we graph it. My graphs are getting slightly better. And we can go the other direction too. So here, following this, at negative pi over 4, where are we going to be at? We're going to be at negative 1, then 0, and then positive 1, and then we'll have an asymptote here. So my graph, and there is cotangent function. Very similar to tangent. The graph, if you notice, is just curved the opposite direction. So why don't you go ahead and work on worksheet T12, finish those up, and if you have any questions, go ahead and ask me. All right, have a great day.